Hello my dear students, today we are going to discuss about surface areas and volumes topic, which is very important in your final exam. So today we will discuss about what are the important formulae for all these different types of solids, LSA, TSA, volume of all these solids. Then we will also discuss about how to find out surface areas and volumes of combination of solids. Now let us discuss how to write LSA, TSA, volume of all these solids. First cube we have. For a cube we will take side as A. If side of the cube is A, then LSA. LSA means what? Only lateral faces, side faces. When you take side faces, 4 faces will be there. Each face is a square. So area of square is A square. That's why it is going to be 4A square, 4 times side of the square. Now when we talk about total surface area, it is including top and bottom. So 2 more faces will be added. 6 times area of square, that is 6A square. This is what? TSA of cube. And then volume. Volume means what? It is a space occupied by the solid. So this is given by A cube. A cube. Now here one more important concept what you have to know. Diagonal. If you want to find out diagonal of a cube, means what? The length from one corner to another corner. This distance we call it as diagonal. So if you want the diagonal of a cube, here I am writing diagonal of a cube is root 3 times of side. Try to remember this. That is diagonal of a cube. Now coming to cuboid, in cuboid we will be having length, breadth, height. Okay, these all faces will be rectangles here. So if you want lateral surface area of a cuboid, then you have to use the formula 2 times h into L plus B. 2h into L plus B. Then total surface area of a cuboid is what? Top and bottom also it will be included in that. So we get 2 into LB plus BH plus HL. This is what? Total surface area of a cuboid. Then volume of a cuboid. It is length into breadth into height. L into B into H. That is what? Volume of a cuboid. Here also there will be diagonal. Length of the diagonal from this point to this corner to this corner. If you want to find out length of the diagonal, here the formula is D is equal to root of L square plus B square plus H square. This is what? Length of the diagonal of a cuboid. Remember this also, because sometimes they give questions related to length of the diagonal also. Now coming to cone, we call it as curved surface area or lateral surface area. Both are same. So here curved surface area of a cone is what? Pi r L. Here r is radius of the cone and L is slant height of the cone. Sometimes slant height will not be given, only height will be given. If height is given, you can observe in the figure there is a right angle triangle formed by height, radius and slant height. So when right angle triangle forms, we can use Pythagoras theorem. So from Pythagoras theorem we get L is equal to root of r square plus h square. This is what? Formula to find slant height. Once you know slant height, then you can find out lateral surface area of the cone. Then what? Total surface area. How can we find total surface area? Pi r into L plus r. This is the formula to find total surface area of a cone. Once you know total surface area, volume. How to find volume? 1 by 3 pi r square h. This is the formula to find volume of a cone. Now coming to cylinder, lateral surface area of a cylinder is 2 pi r h. 2 pi r h, where radius is r and height is h. Then total surface area, top and bottom will be included. Then here 2 pi r into h plus r. This is what? Total surface area of a cylinder. Then volume of a cylinder. Volume of a cylinder is pi r square h. Pi r square h. That is 3 times volume of cone. So this is what about cylinder. Now coming to sphere. For a sphere, lateral surface area is, for a sphere lateral surface area, total surface area differently we do not have, only surface area will be there. That is what? 4 pi r square. Both we will take it as 4 pi r square only. Then volume is 4 by 3 pi r cube. This is the volume of sphere. Now coming to solid hemisphere. If it is a small solid hemisphere, we should take that top surface also. It is a circle. When you find out total surface area, top face area should be considered. Now lateral surface area or curved surface area of a hemisphere will be 2 pi r square. Total surface area of a solid hemisphere is 3 pi r square including top, 3 pi r square, and the volume of a solid hemisphere is half of the volume of sphere, that is 2 by 3 pi r cube. You have to remember all these formulae to find out surface areas and volumes of any type of combination of solids. Discuss how to find surface areas and volumes of these combinations. Now if you see first one, it is a combination of cone and hemisphere. So if you want surface area here, surface area of this solid will be, see which area is exposing outside. For that solid, which area is exposing outside? Only the curved surface area of cone and the curved surface area of hemisphere, but not the bases. Why? Because both the bases are going inside. So you can observe both the bases are going inside. So we will not consider here bases, only CSAs we have to consider. So what will be surface area now? Surface area of this solid will be equal to CSA of cone plus CSA of hemisphere. So what is CSA of cone? Pi RL. Before we have seen pi RL, and CSA of hemisphere is what? 2 pi r square. So in these two you can observe pi is common and also r is common. So we have pi r is common in these two. So you can take pi r common, pi r is common. So if you take pi r common, we will be having pi r into L plus, here 2 will be left and r will be left. So pi r into L plus 2r square units. This is what? Surface area, total surface area of that solid or surface area of that solid. Similarly, we can find out volume of the solid. Volume of the solid is nothing but volume of cone plus volume of hemisphere. So volume of cone is what? 1 by 3 pi r square h plus volume of hemisphere is 2 by 3 pi r cube. We have seen before. Because both are having common radius. What is common in these two? You can have pi r square common and also by 3 common. Pi r square by 3 is common. Then what is left over inside? H plus here 2 times r will be left, because we have taken only pi r square by 3, 2 will be left and r will be left. So this is what? Volume of this solid. Anyway, in question those values will be given, radius and height. We can substitute in the formula and find out the volume or surface area. Now coming to this solid, it is a combination of both cylinder and hemisphere. So here how can we find surface area? Surface area is what here? If it is a hollow cylinder or empty cylinder, then what happens? There will be no top. If there is no top we will not consider. Only CSA of cylinder and CSA of hemisphere we will consider. Then we will take it as CSA of cylinder plus CSA of hemisphere. If it is solid cylinder, then you have to take the top of the cylinder also we have to consider if it is solid cylinder. Here we are taking it as empty cylinder, so only CSA of cylinder and CSA of hemisphere should be taken. In this case, what is CSA of cylinder? CSA of cylinder is 2 pi r h, you have to remember it, plus CSA of hemisphere is 2 pi r square again, like before. Now in these two, what is common? 2 pi r. In both 2 pi r is there. So 2 pi r is common. I have not written 2 pi r square, it is 2 pi r square. So now what is common in these two? 2 pi r is common. 2 pi r if you take common, here h will be left, h plus here only one r is left. So this is what? Total surface area of this solid. Here this is total surface area of the solid. This is volume of the solid. This is total surface area of the solid. Some students, they confuse when they ask you to find out surface area or total surface area. They add total surface areas, total surface area of cylinder and total surface area of hemisphere. That is wrong, because both the bases are going inside. So we will consider only curved surface area. Similarly, now if you want to find out volume, volume is no confusion. Volume is simply we have to add both the volumes. Volume of cylinder plus volume of hemisphere. So what is volume of cylinder? Pi r square h. What is volume of hemisphere? 2 by 3 pi r cube. So in both what you have? Pi r square is common. If you take pi r square common, pi r square we have to take common, then what will be left? Here in first term we have h, plus in second term we have 2 by 3 into r is also left, because r square we have taken common, r is also left. So this is what? Volume of the combination of this solid. Hope you understood this. Now coming to that solid, there what we have? We have a cone and cylinder. We will be having like some questions, tent, conical tent, where base will not be there, because they ask you about to find out a canvas cloth. We will not take canvas cloth down, so we will not take base. So if it is a solid cylinder, again we have to take the base, but when they ask you about tent or if it is empty cylinder, no need to consider base. So here also surface area, when we find surface area, when you want, what we have to do? CSA of cone again plus CSA of cylinder. CSA of cone plus CSA of cylinder. What is CSA of cone? We know pi r L plus CSA of cylinder is what? 2 pi r h. 2 pi r h. So what we get here? A is equal to, pi r is common in both. So here we have L and there we have 2 times h. This is what? Surface area of that solid. Now if you find out volume, volume of solids is simple. Then again what? Volume of cone plus volume of cylinder. So what it is? Volume of cone is 1 by 3 pi r square h plus volume of cone is 1 by 3 pi r square h, volume of cylinder is just pi r square h. But here we have to remember one thing, both the heights will not be same. So we have to take first height as h1, cone height h1 and cylinder height h2. They may be different, so they may not give you same. So this one we have to take it as h1, this one we have to take it as h2. Otherwise you will get again wrong. So what? But common radius will be given, heights may be different. So when common radius are given, pi r square and pi r square is common. So you can take pi r square common here, pi r is common. So if we take pi r square common, what will be left? Pi r square into, we have here 1 by 3 h1 plus their h2. So by using this formula, we can find out volume of that solid. So we have to find out LSA, TSA volume of individual solids, write all together, then take the common, then we get final formula, substitute in that all the values given in the question, then we get very easily. Now for this solid, again surface area, it is a combination of 3. Surface area will be what? CSA of cone plus CSA of cylinder plus CSA of hemisphere also. Now that is what area, surface area is equal to what all we have, pi r L plus 2 pi r h plus 2 pi r square also we have, because hemisphere is there, 2 pi r square. In all these common radius we have, common radius is pi r, so everywhere pi r is common, we will be having pi r common. So this is what radius, this is also radius r, this is what height h1, this is what height h2, height of the cylinder is h2. Then according to that only we have to take here h2 it is. So now pi r if you take common, what will be left, L plus here 2 times h2 plus here 2 is left and r is left, 2r. So this is the surface area of that solid. So coming to volume, volume if you want, what you have to do, all the volumes we have to add, volume of cone plus volume of cylinder plus volume of hemisphere, all the volumes we have to add. Then what we get, volume of cone is what, 1 by 3 pi r square h1 plus volume of cylinder is pi r square h2, because height of the cylinder we have taken. Then this is what, 2 by 3 pi r cube. Now what is common in all this, pi r square is common, so you can take pi r square common. So if you take pi r square common, here I am writing, what will be left, pi r square into 1 by 3 h1 plus here only h2 will be left plus here 2 by 3 r, 2 by 3 r will be left. This is what volume of the solid. Hope you understood these 4 solids, surface areas and volumes of combination of these solids, how to find out. We will see in next page. We are having some more combinations in the same way. So this is what combination of 2 hemispheres on either side and 1 cylinder. We have some problems related to petrol tank, capsule, all those problems are related to this solid only. So here what surface area will be, surface area we can write it as 2 times CSA of hemisphere, because 2 hemispheres are there, 2 times CSA of hemisphere plus CSA of cylinder. So what we get, area is equal to 2 times 2 pi r square, which is nothing but finally we get area of a sphere. So here this is what radius, this is also common radius, and this is what height of the cylinder, and CSA of cylinder is what, 2 pi r h, so which gives us 4 pi r square plus 2 pi r h. So finally area will be, what we have common here in these two, pi r is common. So if you take pi r common, we will be getting here 2 pi r, 2 is also common, 2 is also common in both. So if you take 2 pi r common, then what is left here, 2 r plus here 2 h. This is what area of that solid. Now volume, volume is equal to again 2 times volume of hemisphere plus volume of cylinder. So that is what, 2 times volume of hemisphere is 2 by 3, 2 into 2 by 3 pi r cube, which is volume of sphere, plus volume of cylinder is pi r square h, which is further 4 by 3 pi r cube plus pi r square h. So in these two, what you have common? Pi r square is common. So we can write it as volume is equal to 4 by 3, pi is common, r square is also common, 4 by 3. So 1 second, we have to take common here. When you take common, what we have to take common? Pi r square we have to take common, then inside we will get 4 by 3 into r plus h. This is what volume of combination of that solid. Now coming to here, what we have, what is happening here? Two hemispheres are scooped out, means it is opposite. There hemispheres are attached, here hemispheres are removed. Even though those are scooped out, they are removed, hemispheres removed, but there is no difference in surface area. You have to keep this in mind. When you attach two hemispheres or when you remove two hemispheres, there is no difference in the surface area, because surface area is going to be added when you remove hemispheres. So here what happens again? Surface area, there is no difference. I am writing directly what 2 times CSV of hemisphere, 2 times 2 pi r square plus 2 pi r h, same thing. Then it is 4 pi r square plus 2 pi r h. Then we can take 2 pi r common, then we will be having 2r plus h. This is what surface area of combination of solid. Area of combination of solid. Now volume, but volume there will be difference, because their space will be decreased when you remove two hemispheres. So here what volume will become? Volume of cylinder. We have to be careful here. When it is surface area, there is no difference, but when it is volume, you should subtract volume of 2 times volume of, not 1 time, 2 times volume of hemisphere. So it should be subtracted here. So it is going to be pi r square h minus 4 by 3 pi r cube, because finally it is going to be a sphere. So from these two, what you can take common? Pi r square we can take common. So it is pi r square into, what will be left? H minus 4 by 3 r. So same there, h plus 4 by 3 r, here h minus 4 by 3 r. So volume is equal to pi r square into h minus 4 by 3 r, where h plus 4 by 3 r. This is about surface areas and volumes of these two solids. Now coming to there we have a cube and a hemisphere is attached to it. A hemisphere is attached to cube. So in this case what happens? Here it is a special case. Surface area, when you want to find out which area is exposing outside. Surface area, which area is exposing outside in this case? 5 faces are as it is. 5 faces of cube are as it is, but only the top face. In top face, this circle area is going to be removed. Circle area is going to be removed. So this circle area should be subtracted from the total surface area of the cube. So what? 6a square minus circle area should be subtracted. That's why pi r square. Then total, this curved surface area we are adding. Circle area we are removing, but this curved surface area we are attaching. So that's why we have to add curved surface area plus 2 pi r square. So minus 1 pi r square plus 2 pi r square is going to be 6a square plus pi r square. We have to remember it. So finally here area, surface area or area is going to be 6a square plus pi r square. If it is maximum, if you want maximum hemisphere, maximum diameter of hemisphere, then you have to remember this relation. Diameter of hemisphere will be equal to side of the cube. In that case, A will be equal to 2 times of R. We have to remember this in this type of problems. Or R is equal to half of A if the diameter, if you want the maximum diameter of the hemisphere on the cube. Now volume, what happens here? We have to add both. Volume of combination of solid is equal to volume of cube plus volume of hemisphere. So here what happens? Volume of cube is a cube plus volume of hemisphere is 2 by 3 pi r cube. If you want to simplify further, we can substitute a is equal to 2r and simplify, but remember like this, later you can substitute the values and simplify it. In the second case, hemisphere is removed. In the previous case, hemisphere is attached, but in the second case, hemisphere is removed. When hemisphere is removed, again like before, there is no difference in surface area. We have to remember, surface area will be same when you add or remove hemisphere in the previous case and here also. So here what happens again, 6a square as it is, and one circle area should be subtracted, minus pi r square, and the curved surface area should be attached because curved surface area is going to be added here, plus 2 pi r square. So finally it is going to be again 6a square plus pi r square. This is what? Area. Now volume is different. Before we added, but now we have to subtract. So what is going to be volume now? Volume is equal to volume of cube minus volume of hemisphere. So that is going to be a cube minus 2 by 3 pi r cube. There we added, here we have to subtract. So these are going to be surface areas and volumes of these 4 combination of solids. Now coming to next type, here we can see like this also, you will be having sometimes question. So what happened here, one cone is removed from the cylinder, then they ask you to find out surface area and volume. Here there will be 2 cases. If cylinder is solid cylinder, then there will be bottom, base area, circle area we should add. If it is empty, then there will be no base area, no need to add. Generally we will take it as a solid cylinder. From solid cylinder we remove one cone. So you have to read question carefully whether it is solid cylinder or empty cylinder. If it is solid cylinder, what happens? We want surface area here. If it is surface area, if you want surface area, it is going to be, because you are removing cone, there will be no top, only CSU of cylinder will be left plus CSU of cone we have to consider, plus base area also we have to take because we are considering it as solid. So in that case what happens? 2 pi RH plus pi RL plus pi r square. What is common everywhere? Pi r is common, so you have to take pi r common. If you take pi r common, pi r into 2h plus L plus R. This is what? Area. Now if you want volume, what we have to do? Because you are removing cone, it is simply volume of cylinder minus volume of cone. So what it is? Volume of cylinder is pi r square h minus 1 by 3 pi r square h. You know, here everything is same because they both are having same radius and same height, so you can simplify it. You know, finally what we get? 3 pi r square minus 3 pi r square h minus 1 pi r square h. 3 minus 1 2. So it is what? 2 pi r square h by 3. This is going to be volume of that solid. We can substitute radius and height in the formula directly and you can find out. This is the volume concept. Now coming to this one, here what happened? we have to find out the maximum volume of cone that can be scooped out from the cube. So in that case, what happens? Radius or diameter of the cone will be equal to the side of the cube, like before. A is equal to 2r. So here if you want surface area, again what we have to do? Surface area, when you want, what we have to do, like same like hemisphere only, 6 faces as it is, 6a square minus circle area should be removed, minus pi r square. Then cone surface area should be added. Cone surface area, when you add CSA of cone should be added, like 2 pi r square have we added. Now CSA of cone should be added. This will become pi RL. So then later, because okay, you can substitute here, A is equal to 2r, substitute, and then we can take common, but you remember this part. Okay, 6a square minus pi r square plus pi RL, in that you have to substitute and find out. Now volume, what to do? Volume of this solid will be equal to volume of cube minus volume of cone, that is a cube minus 1 by 3 pi r square h. H is equal to, H is nothing but, here one more concept also you have to remember, H is nothing but R only, H is nothing but A only, A and H are same. So H is equal to 2R or H is equal to A. Hope you will remember this. Right. Now this is about these two solids. Now coming here, this figure you may not understand. Here what I thought to tell you, this is the cylinder. From cylinder we are removing two cones. From cylinder we are removing two cones. This is one cone, two cones are removed. Then how can we find surface area? Because two cones are removed, there will be no top, no base also. So what will happen? Surface area is equal to CSU of cylinder, that will be as it is because that will not be affected. Now top is circle removed, because you are removing cone, circle is removed, but CSU of cone is added. Even bottom also circle is removed, but CSU of cone is added. So 2 times CSU of cone is added. Hope you understood. 2 times CSU of cone is added. So it will be pi r 2 pi r h, 2 pi r h plus 2 pi r l. So we can take 2 pi r common, it becomes h plus l. This is what area. Now what is volume? Volume is simple. Volume is equal to volume of cylinder minus 2 times volume of cone. That's it. That is what? Pi r square h minus, here h1, h2 will be different. h1 and radius is common. If radius is different, radius also r1, r2 we have to take. 2 into 2, 1 by 3 pi r square h2. In this we have to substitute and simplify the value, we get volume of that solid. Now coming to here, two cubes are attached. When two cubes are attached, surface area we find, it will become a cuboid. When two cubes are attached, it will become cuboid. So how can we find surface area of this solid now? For this cuboid, length will be equal to 2 times of side 2a, and breadth will be equal to a. Even height is also equal to, breadth and height both are equal to a. So this is breadth is side of the cube, even height is side of the cube, there is no change. So we will substitute all those in formula. 2 into LB plus BH plus HL formula we use. Here we will substitute all those. So what happens, 2 into 2a into a 2a square plus a into a square plus again a into 2a 2a square. So it is 2 into 5a square, 2 into 5a square is 10a square, you remember this. If two cubes are attached, then the surface area of cuboid is what? 10a square. Volume is simple, volume is what? 2 times volume of cube, nothing but 2a cube. Hope you understood this. So these are some very important concepts and formulas. Hope all these will help you a lot in solving problems in your board exam. The first thing is what? All the LSA, TSA volume of all the individual solids you have to remember, and then you have to observe the figure carefully, in which case you have to add or in which case you have to subtract, you have to know. Hope it will help you a lot. Share to your friends. Thank you.